This is Unit 5, Lesson 2, Transformations as Functions. Before we get into the transformations, let's start out with a review of functions and what functions are. So remember that a function is a relation between two sets of data. So in a function, we have our input, what we plug in, and then the thing that we get out is called our output. So let's say we have the equation y equals x plus 2. We're going to make our input for this example x equals 5. So if we have an input of x equals 5, that means that 5 is going to replace x. So y equals 5 plus 2 turns into our output of 7. So we take our input, we plug it in, and then we get our output. We also learned how to do this in function notation. So we can take the same equation, but instead of saying y equals x plus 2, I'm going to say f of x equals x plus 2. If my input is x equals 5, f of x is going to turn into f of 5 equals 5 plus 2. So every x gets replaced with a 5 because that is now my input. The output is still going to be 7. So when my input is 5, my output equals 7. So let's take that idea of a function and let's apply that to transformations. As you know, there's 3 types of transformations that we are focusing on right now. Those 3 types are rotation, translation, and reflection. So when it comes to transformations, our input, rather than the input being x, in a transformation, our input is going to be an entire ordered pair. So the input would be x, y. The output would be whatever transformation happened. We're just going to represent that with an f, and then the ordered pair. So let's look up here again at function notation. The input was x equals 5. The output was f of 5 equals 7. We have the same sort of thing going on. We have our input, and then our output over here has some sort of identifying character, and then the output. So let's say I have transformation f of xy. We could write that by saying x plus h, y plus k. This would be an example of a translation. The reason I identify this as a translation is that h represents a horizontal shift, so it tells me how far I'm going to be moving to the left or right. And K represents a vertical shift. It tells me how far I'm going to be moving up or down. And we know that translation is when we're basically just sliding a shape around. So, for example, we could have something like the translation equals x plus 2 and y plus 1. That would tell me, since it's plus 2 on the horizontal axis or on the x-axis, positive means we go right. And since it's plus 1 on the vertical axis, vertical means, or positive means up. So I'm going to go up 1. That would move my whole figure right 2 spaces, up 1 space. Another type of transformation we could have would be a transformation that goes x and then negative y. This type of transformation is a reflection. And since we have a negative y value, this would be flipping over the x-axis. And all of our y values would become negative. Or if they were already negative, all the y values would become positive. So this is kind of like the general notation that you see. Another part of the notation is that we will see transformation T, meaning translation of xy on point P would become T of P, which becomes P prime. Now, that part right here might have been kind of like a foreign language to you. So let's walk through this and what it's meaning. We have a transformation T of xy. This represents our output. Just like up here, f of x represented what was going to be our output. We just didn't know what it was yet. So right now, I know that this is going to be my output. I just don't know what the output is yet. So we're doing a translation, and we're translating point P, or we're sliding P to a new place. So we're taking this P and we're replacing it inside the parentheses. Whatever the coordinate is for P, that's what's going to go in place of x and y right here. So whatever T of P ends up equaling, T of P, we'll call that P prime because that is the image. We go from the pre-image to the image. P is the pre-image. We plug the pre-image into our notation, which is how we get T of P. And then our pre-image gives us our image P prime. Let's apply this to an example. This notation is kind of funky, and it takes a few examples to really get used to it. So for example number 1, we're going to start out with point P at the location 5, 3. This is, you could call it our pre-image. This is where we are beginning. And I am told to do the transformation, or the translation, T on xy. And my translation is going to equal x plus 2 and y plus 2. The question is, what is T of P? So let's look for a second at that translation that we've got going on here. I'm told that we're going to do x plus 2, so I'm going to have a horizontal shift that's going to take me right, and then I'm told y plus 2. We're going to have a vertical shift that's going to take us up. So let's plug these things in. T of x, y, we want to find t of p. So instead of writing t of x, y, let's go ahead and write it as t of p, okay? Or t of the point p, or t of the coordinate for p, which is 5, 3. I'm going to take that 5, 3, and I'm going to put it in place of the parentheses instead of p. So let's compare this to regular function notation. Regular function notation, we have f of x equals x plus 2. And then we take that 5 right here, and we put it in place of all the x's. So t of p equals 5/3, or t of p, I know that p is 5, 3. So instead of p, I'm going to write t of 5, 3 equals, we put a 5, 3 in for x. Now we need to replace this x with 5 and this y with 3. So I'm going to have 5 plus 2, and then replacing the y with a 3, that will give me 3 plus 2. And that ends up equaling 7, 5. So we can say that t of p equals 7, 5. Or in other words, the transformation of p ended up equaling or moving us to the point 7, 5. I could also, instead of saying t of p, say p prime is 7, 5. I got that little mistake. Pretend like that's an equal sign. P prime equals 7, 5. Let's look at another example of this function notation for transformations. This time, for example number 2, rather than looking at a single different point, we're going to look at 3 different points, okay? So we're going to look at triangle ABC. Remember, triangle ABC has to be made up of 3 points, point A, point B, and point C. Point A is found at the coordinate 5, 2. Point B at the coordinate 3, 5. And point C is found at the coordinate 2, 2. So this is our pre-image, essentially. We're going to take that pre-image and we are going to do a translation. Our translation is of the point xy, and it equals x negative y. So I'm going to do this 3 times. First, we're going to do a transformation on A, then we'll do a transformation on B, and then we'll do a transformation on C. So let's start out with the transformation on A. A was at the coordinate 5, 2. So I'm going to write transformation of 5, 2 inside parentheses equals, it's equal to x negative y. So I just replace the x with my x value, which is 5. And then I have to bring this negative over, and then we'll replace our y value with, or the y with our y value, which is 2. So I come up with 5, negative 2. That means A prime is 5, negative 2. Now let's do it for B. We'll do a different color so we don't get confused. So B was at the coordinate 3, 5. So I have my transformation on 3, 5. It equals, we do x negative y. My x value is 3. I bring a negative, and my y value was 5. So we end up with t of b equals 3, negative 5. Or we can just say that b prime is at 3, negative 5. And finally, we have t of c. Well, c was at the coordinate 2, 2. So I do t of 2, 2 equals, and the transformation we are told, once again, is x negative y. So we have our x value, which is 2. We have to bring the negative, and then our y value was 2. 2, 2 became 2, negative 2. So t of c equals 2, negative 2, or we can just say that c prime is at 2, negative 2. Let's take a second and just plot this out. You don't necessarily have to do this in your notes, but I want you all to be able to see what just happened when we did that notation. So we'll do our pre-image in this green color. We start out at 5, 2. 1, 2, 3, 4, 5. 1, 2, 3, 5. And 2, 2. So we've got point A, B, and C. That makes our original triangle. Then we have in orange our image. So A prime is at 5, negative 2. B prime is at 3, negative 5. And C prime is at 2, negative 2. Now you'll have to forgive my not exact drawing. I'm afraid that's not quite perfect, but you can see that this image was taken and it was flipped upside down over the x-axis down below. We are going to do more examples of this in class. It's definitely a little bit confusing. It's kind of like we're reading a foreign language right now with all of these notations and all of these letters and numbers that we're replacing. So if you're feeling confused right now, don't be concerned. You might want to write down a couple questions that you have, maybe the things that confuse you the most, and make sure you ask when we get to class and go over this together tomorrow.